Hello, audio. Right, so let's just have a quick explanation. I think Josh has got the answer there, but I'm going to ignore him purposely. So if you've got 35 watts output wattage, you have losses, heat losses, that we discussed in day 3. So from Eskom, you're drawing more power. So if you take 35 divided by 88%, so 35 divided by 0.88, we are drawing from Eskom 39.77 watts. Does that make sense? Yes. Okay. So if we use a nominal voltage of, let's call it 240 watts, so we go back to that that little formula of ours, if you guys see my page here, okay, P VI. So I equals 240, 35 divided by 240. Can anybody give me the answer? So, just to answer you guys again, it is 165.165 amps. So remember, I equals 35. Who's on mute? I'm just going to mute everybody. Okay, someone was making noise on that side. Morning, Bianca. See, you're also not part of things. Someone was making noise. Okay, so we've got 35 watts divided by 240. So we're looking at 0.165 of an amp. So if you got an ICL 28, right? An ICL 28 can supply you 28 amps. So 28 amps divided by 0.1657 will give you 168 power supplies. So the answer is not 6, Natasha. You're on silent.
Okay, on discussion with somebody, we thought it was only 1 because the LRS draws 45 amps on startup and the ICL's maximum inrush is 48 amps. So why is it not 1?
Because it limits it. So if we have a look at, let me just go to day 3. That's a very valid question. So training presentations. So I've got the ICL here. I'm just going to open it up. Can you guys see this from my screen? ICL.
Yeah.
So if you look at this screen there, okay, you've got your live and neutral coming in and your live and neutral going out. To explain to you, I have this little thing. So you've got live and neutral and ICL coming in here. So it's an AC to AC converter, and on the power supplies, we've got power supplies we can connect. Okay, so we can connect a quantity of 165. Okay, now because of that circuit there, the control circuit, it actually limits the amps. So that's a box of tricks that they've designed and come up with to limit that inrush current. So it actually dampens the inrush. So you're not looking at the full inrush of a power supply. So if you ignored the ICL, ignored that portion right there, right, then you would definitely have the problem of that 45 amps coming in. But because you've added that thing, you can now add, you just look at the amps. Okay, okay, so just, I was more behind the mathematics, okay, than the rest of the stuff. But it's basically, it's been designed in such a fashion to limit that inrush current. But it's because of that circuit. So it actually only brings it in at a certain, at a stage. Okay, but that is maybe just a feedback. I think one of the questions that you specifically had is how do you connect this thing, because it didn't seem obvious. It's not like a power supply which you just put power onto it and off you go. Okay, but we are not on page 3 today. We are going to be on page 4. So let's just find my page 4. Okay. So today you will see that my audio does work. So what is vibration and shock? And just to encapsulate the question of where we look at. So we look at the power supply. Yeah, last time we spoke about setup rise, all that kind of voltages, the cold start, the inrush, that we've run through it. Now one of the things is the environment that we're looking at. So here, that portion there where it speaks about 10 to 500 hertz, 5 Gs. Now I think we assume that everybody knows what is shock resistant. So if we all think of 5 Gs, we think of aeroplanes. I'm just going to have a quick browse there. Like a just put the volume down. So you've got, for example, like a car moving at very high speeds, and that obviously jerks the people around, and that's what causes the G-forces as such. But it's the same with a vehicle, like we spoke the last time about a truck, where you've got balancing in all axes. But if we look, and this is what I actually wanted to show you guys, was this little video here. So yes, it's maybe 6 minutes. I'm just going to forward it to an area like this. So maybe just to explain to you a little bit earlier, so they've got machinery that they jerk the equipment up and down in all different directions. And MeanWell has these equipment as well, where they literally vibrate the equipment, and then they start looking and analyzing how the power supply reacts. Now if you look at this video here, and this is the portion in which I wanted to show you, you see how it oscillates in all the different directions, and all of that has stresses on the power supply and the components, and they look at it from a close perspective, and they see, right, this power supply is going to break apart. So that's what the video is all about. You know, if you guys want to just listen to it in your own time, you'll see what the effect of 5G is on power supplies and how good it is really for the MeanWell to have such high forces. Because if you start looking at the competition does not have such high G forces on their product line, or actually never even states the obvious thing. So it says the vibration resistance indicates the mechanical strength against the vibration when the power supply receives vibration due to periodic force during transport, storage, or operation. So it's even from a, you know, if they put the thing on a ship or an aeroplane or a truck, you know, someone takes a box and they throw it, is that box going to damage the power supplies as it as it gets transported to us? So that's the portion of it, and obviously during the operations of it as well. Okay, so that's why they state it. No one can really determine what the actual G forces the thing is working in unless you test the whole truck, and that is pretty much impossible. So the next thing I want to refer to there is they're talking about the working temperature. Obviously we know what the minus 30 to 70 degrees is. 70 degrees is the maximum. We spoke about the duration curve, about the thing. But also the same is for the negative. So if you're working in a cold environment like Canada, so then your electron flows, your ion flows inside your equipment becomes a lot more stringent under cold temperatures, and it's almost like it works like in molasses. So it doesn't really want to operate, and it becomes problematic. Now once the electronics are going, it builds up heat, and so the energy starts flowing. But if you do it from a cold start point of view, those are the kind of issues that you do find. So just maybe an explanation for you guys. I'm not going to really go through this video. I'll just put the volume down, where they just explain to you that the volume on a is more in a heated environment than a cold environment. Okay, which means that if you start looking at the liquids, you've got more condensation in heated environments, and that's why you'll find especially if you go from like a hot car, and you go into an air conditioned environment, like your sunglasses would fog up. You know, obviously if you've been in places like Dubai or the desert, you'll definitely experience it. Even on a hot summer's day in South Africa, you'll find that. Now that same effect is on a power supply, so you don't want that condensation. on the power supply because the condensation will create conductivity. You know, so just a quick video here as well. You'll see the guy has a glass here full of water, so obviously as he transfers the water into the bigger jug, it's the same amount of water, it's just less, you know, it's more volume, and that refers to temperature. And obviously as it comes down, putting it in a small jug, you know, it's overflowing. And the same concept with the power supply in terms of temperature is that it overflows if you're in a heated environment. Okay. This is an explanation of what temperature coefficient is. It's a little bit more technical. I'm not going to go through. I think you need to go through it on the video because my explanation is just going to be junk. I think 99.999999% of the time a client's not going to ask the question, but you can have that mad professor that's going to ask you what is the temperature coefficient, because he needs to determine what is the beginning temperature and the end temperature of the actual power supply and what effect does it have onto the thing. And therefore you can watch this little video which explains to you what it's all about. Just explaining to you ambient temperature, the allowable range for the ambient temperature in which continuous operation is possible. So I think that's the most important summary, and what most people care about is that. And then coming back again to what I said, is always try and offer 60% load, which will give you the maximum temperature environment. So when you size a power supply for someone. Now, I know it, but I think most of you guys don't know what conformal coating is. Now, if I look back, so I just want to get you guys here again. Shaylin, do you know what conformal coating is? It's very important there where you are. Yep. Do you know what it is?
No, I don't.
Joshua, do you know what it is?
Yeah.
Okay. And Bianca, do you know what it is? Okay, so it's maybe important that I do refer to it. So now conformal coating, if you have a quick look here, in terms of the video, so they basically put a lacquer spray. So let's just go back here. Yeah, maybe there. It's something like this, which they spray onto the boards. So if you look there, it's like a silicone layer that they actually put on. It's like a varnish. So as the humidity rises in a power supply, now think of something that is sitting next to a highway or next to the coast. We've had many of that scenario. So if you look at the Cape Town against the poles, or even Durban, we've got equipment outside, and as the temperature changes, or humidity, there's mist, all that kind of stuff, your power supply is actually affected by this humidity because we now supersede that humidity level. Okay, and that has an effect to destroy the power supply. You'll find some of the power supplies rusted and they stop working after a period of time. So if a client specifically is not going to use the equipment indoors, we can either conformal coat it for the client, but it's problematic because we have to strip the power supply, okay, spray the lacquer onto it, or if it's a high volume, we can ask MeanWell to actually do that for us. They then conformal coat it for us, so they spray it, they create it. If you look at typical like the inverters, all the inverters that come in from overseas are, for example, like Victron is conformally coated because they are used in ocean environment. And obviously the item that supersedes conformal coating is potted. Okay, we start looking at the potted environment. So just explaining to you, this LED screen, someone sprayed it, and basically there it operates. You can shove that thing into the water and it will still operate. But that also has an impact. You can't conformal everything because now you've got heat, you can't dissipate the heat so easily. Okay, so it does have a great impact, especially in agricultural equipment, cars, industrial outside equipment, food and beverage. You also have those scenarios. And coming back again to MeanWell's explanation, you have over voltage. So this area here. Okay. So what is over voltage? An over voltage should never occur unless there is a malfunction. So if there is a malfunction in the power supply, this protection function detects overvoltage and interrupts output to prevent sensors or other loads from being subjected to excessive voltage due to failure of the power supply's internal circuit. So our power supply may be $1 or $2, which is a low value, but the equipment that is being connected to could be $1,000 or $10,000, and a slight overvoltage will pop that thing, which is $1,000 down the drain. So what MeanWell then does is they offer that overvoltage protection. You would actually never ever see that in operation, because even if it does fail, the power supply would actually stop working. So it shuts down, and you'll always find the power supply rises again if you switch the power on and off, and it collapses again. They'll tell you the power supply is faulty. But at least you won't have a lawsuit on your hands of equipment being blown up. Okay. So I think the next thing which is quite important for us is voltage drop. Okay. And that comes in when we have a power supply over a very long distance. I think we spoke about that the other day. So you have a power supply, and maybe 100 meters or 200 meters or 300 meters or a kilometer away is the requirement. Now, we've had clients ask us the question, is that they wanted to supply power on an airfield, but they're concerned about the voltage drop. Okay. Now, if you have a normal power supply that supplies you 12 volt DC, now you've got a long distance, you're going to mostly end up with 10 volts at the distance. So how do you ensure that power supply is actually giving you 12 volts at the end of that load? Now, MeanWell has specific power supplies, and we need to go and look out for these power supplies. It has a voltage sense circuit. So you're supplying that voltage, and you've got a feedback. So if you, for example, supply 12 volts, at the end you're going to get 10 volts here, so it's a 2 volt drop. But now if you send that signal back, you're going to lose another 2 volts. It's going to see at the power supply 8 volts here. So then it knows, right, there's a 2 volt difference. I need to raise that 12 volts to 14 volts so that you're going to have 12 volts DC on your load. And that's what the voltage sense is about. Now I think more for the engineers, this is a very important calculator here, and I've given you the length here. So for example, we're supplying we're going to be supplying DC, we're going to be supplying 12 volts DC, we're having a single conductor, okay, so it's only one cable, and we're going to make it 500 meters, okay? And we're going to be running maybe 20 amps through it. So if you look there, this portion here of the calculator, it shows you that your voltage is 8 volts at 500 meters. So if I'm going to make that maybe 200 meters, you see the voltage, okay, changes. You see the voltage on 10 meters is 0.16. So not all power supplies and all distances has an issue. It's got to do because your cable has resistance in it. It's not a superconductor. You have no resistance. So every cable has a resistance in it. So there's maybe just to explain to you, if you do a lot of cable design work, you'll see that a 4mm cable can go up to 42 amps, or a 1mm is 19 amps. So if a power supply can supply you very high amps, like 50 or 100 amps, that person needs to choose the correct cable, because we've also had that where people supply the wrong cables. The cables become heated. Okay, and like we said before, if your impedance on that thing is very high, the power supply will never see a short circuit, and you actually can pump incredible high amperage into that cable and cause a fire. But that's usually not your problem, it's that you just can understand. Okay, it's just, I think at the end of the day, you must be able to prepare yourself for any kind of questions. Now, this is just a typical wiring, considering a voltage drop. I've given you that portion. And this is typically, you'll see a MeanWell power supply, the larger versions. So there's a little connector there, and you've got your twisted Remember we spoke about why the twisted cable is there for electromagnetic interference, so that you don't have electromagnetic interference because you're running over a long distance. Okay, where they send the stuff back. Okay, now the next question which I want to raise to you. If you've been long enough in the power supply market, you'll know South Africa is sitting at 50 hertz. North America, we sit at 60 hertz. But you'll also find clients asking you for 440 hertz. Now, it's nowhere specified on the power supply that you've got 400 hertz. Okay, you see that? 47 to 63 hertz. That is specifically related to earth leakage. Remember, we spoke about earth leakage, and medical power supplies, you've got a certain amount of earth leakage that occurs at the frequency that is being supplied. So it can accept it. Okay. And why do they do it? It's because of aircraft. So if you look there, there's a slight video of where they've spoken it, and because you've got the higher frequency, so if you listen to this video of this guy, maybe a bit boring, it'll explain to you that your transformer and everything shrinks if you start running with 440 hertz. So there's very specific power supplies out there. I usually stay away from it because there's no warranties that you can offer, although it will work. Okay, and it's up to the client that needs to make that decision. I personally would never put a power supply at 440 hertz into an aircraft, because an aircraft, if it should go down, is not something you want on your hands. But I've had the question maybe 10-15 times in my life where people wanted to use aircraft. So you just revise them that your earth leakage or your leakage current on a power supply is too high on 440 hertz. It will work, but your leakage is too high and is problematic and could shut down. Okay. So I think maybe just important, we spoke earlier about that ICL, and it spoke specifically about the capacitive or inductance loads. Now if you look at a resistive load, it's typically like an element or a light bulb, and inductive loads, that is an inductive load converts current into a magnetic field. So it's typically like a coil like this, and it creates a magnetic field around it. Now if you want to look at the impact it has, okay, you can look at some of these videos where it shows you, okay, this is not this one. Yeah, if you look here, you'll see a normal sine wave that comes through, and as you add inductive, you look at the amps, okay, how it follows, and what's the difference between a voltage signal or a resistive signal, and you can see, and all of that has a major impact on a power supply. And like I said to you guys before, it's like a flywheel. So if you, once you get a flywheel going and you take the energy off the flywheel, that flywheel is still going, it's still creating a motion. Okay, so it either lags or leads the voltage or the current in your load, and has a definite impact on it. So on certain power supplies it has a huge impact, it could damage the power supply. But most of your clients is just purely resistive. But there is certain applications where the clients look more at inductive and capacitive loads, and therefore we go with the more power factor correction power supplies. So I think after today we're going to limit our technical discussions around power supplies. I think we're always going to refer maybe back to day 1, 2, 3 and 4 from a technical aspect. Okay, and always go back to these videos and get it underneath your understanding what all these terms are. If once we go past this, I'm going to look at, for example, like an LRS. What's the difference between an LRS and an RS and a PFC model? So we're going to look at small changes. We're going to look at what we're going to offer the client. But I think there's the important factor is, it's like that power formula, P equals VI or V equals IR. Those are the small formulas that you need to memorize and understand. You need to be able to do the calculations like I've done with an ICL. So if a client asks you, I'm looking for a 24 volt 10 amp, you must immediately be able to say, listen, you've got a 240 watt power supply, but is that your full amps you're drawing? If that's not 60%, you need to add an additional wattage. So if I take 240, divided by 0.6. So you should maybe look at a 400 watt power supply because of the temperature. You understand? So is 10 amps, have you added your safety factor or have you not added your safety factor? What temperatures are you going to vary? Where are you going to be putting your power supply? Is it an open cabinet? Is it internal? Is it external? Do you need conformal coating? All of those are information that you require. And one of the things we are going to be looking at is power factor as well. So I think it's very important. This is also very technical. Just to explain to you as a quick explanation, maybe if we look at this picture here, okay, of a beer. So you got beer, is the real value of the power that you want, and you got fake energy, which is the foam. Or as we've explained to you before, you would like to pull a boat with a horse. So unfortunately you can't put the horse in the water, it has to be to the side. Now you've got an energy flowing in that direction and a flowing, so you've got upwards and a forward energy factor. And unfortunately you are being charged on the kVA Rs, okay, which is beautiful formulas, as well as it from Eskom. So if Eskom does give you a bill at the end of the month, they don't give you just the beer value of it, they charge you the reactive energy of it as well, because they actually need to generate a lot more energy at the power stations to be able to supply you that, and therefore that power factor has a huge impact. Okay, so you always need to make sure that your power factor of your plant, of your power supplies are optimized. Yes, you're going to be paying more, and I think we'll look at the values of the difference between an LRS, which is your cheap version, your RS, which can handle higher temperatures, and then you've got your power factor correction portion, which is even more. But at the end of the day, the cost to run a power factor correction power supply over a 10-year period is cheaper to run an LRS. So if you're trying to gain a market immediately, an LRS is going to be your cheapest. You're going to put that thing in, the client's going to think you've got the best price. But at the end of the day, once he's operated that power supply for 10 years, he would have made the money 10 times over by putting a power factor correction power supply. Okay, because he's paying it on monthly bills. So I think it's a really, really great video about power factor. I encourage you guys to go through it. It's not that one. There it is. So you guys can see what it's all about. It'll explain to you the whole beer thing, what the power factors, the beer analogy, what the energies that you're going to get out of it. So like I said, spend another hour sometime into it, and therefore I gave you guys a lot of time. It'll explain to you in a working environment how power factor is a problem. You know, even from a cable point of view, why the plants have to charge you more money, because you've got cable heating as a result of power factor. So they have to spend a lot more infrastructure. And if you can do power factor correction at your plant, you've got major savings down the line. And then just an explanation for most of you that most don't understand it, I think it's Karina maybe or Bianca, is every part of the world has different voltages. So if you look at South Africa, we've got a mixture of 220, 230 and 240 volts by us. Okay, but in North America you'll find typically 120 volts. Okay, or you'll find even different voltages. You find even 230 but 60 hertz in those areas there, the islands, like Taiwan, those kind of places. No, I like Taiwan is 110, 60 hertz, so it's that little red one there. But yeah, these islands here run 230, 60 hertz, and everyone's got their own little plugs. I think everybody knows what's that about. And just a question, does everybody know that South Africa's official standard is not the 3-prong plug anymore? So if we look at SANS 164, okay, it actually refers to that little, so you got your live, your neutral and your earth. Looks like the European. That is the official South African socket now. This is what you'll find in every house, but all new houses must have a combination between the two. And down the line, they'll, in a few 20 or 30 or 50 years, we're only going to find those plugs in our houses. Okay. South Africa, you'll find a lot of times people ask for the mines up to 500 volts. Okay. Then just coming back slightly to a technical value again, where do we get the the 220 volt from. So we've got transformers supplying you on the outside of your building, and between line and line, for example, between A and B is 380 volts, or on a mine is 525 or 600 volts. So the way that you get it is a little formula there, which is root 3, was a quick value of 1.73. So if you take 380 or 400 volts and you divide it by 1.73, you get to 220 volts. And the same with America. In America, they don't have 300 or 380 or 400 volts AC. They've got 208 volts phase to phase. But if you divide that by root 3, you get to 120 volts AC, but 60 hertz. Okay. So it's maybe important just to look at some of these formulas, get to know it, get to understand it, because down the line, it always boils down to a question, especially people asking for 3-phase power supplies. Because sometimes we do have power supplies, you'll see, and I'll refer back to you, as 220 hertz, 3-phase. So don't get confused. It's in our arsenal is power supplies that can work in different places like this. Okay, it's been designed that way. So South Africa, you will never be able to put 3-phase into it because we don't have that generation. And we've had clients that blown it up. I'll show you out those items that do exist out there. But feel free. I think these videos explain more than I can explain in a few minutes time. It's very, very technical, but spend at least an hour somewhere down the line. Bianca, specifically you, Karina, specifically you, Shane, specifically you, and Tasha, when you have time as well, you can do it as well. And I know Joshua, you definitely don't have the technical background, so it's very important. So maybe just to recap for Simon and Paul, they've known these things and they've worked with it through their education. But these are the technical jargon that is referred to straight out the book. Every single time we refer to a voltage, amps, current, a power factor, efficiency, and you need to work with those formulas. So down the line, I'm going to start asking questions, right? For example, like I've had this morning, how many power supplies can you put on an ICL? You must be able to give me the answer. I'm going to ask you exactly, I would like a 3 amp, 12 volt and 24 volt power supply. What model are you going to offer me? You need to be able to do the calculations. You need to do, okay, volts times amps is so many watts. That's channel 1. Volts times amps, channel 2. That's the approximate size of power supplies, because otherwise you'll never be able to give a client the correct answer because you're always waiting for him to give you the answer. You are the technical person to help sell that thing. You are the technical person that needs to be able to give it. So you'll never really go beyond this portion. And if you do have questions, you must always just refer it back to an engineer. Okay, so that's my 30 or 40 odd minutes for today. And yeah, please work through it and I'll definitely ask questions. Anything from you guys? Questions? Nothing? Great stuff. Thank you very much, and we'll work on it again tomorrow. Okay, bye.
Thank you.